Welcome back, everybody. In this video, we're going to perform optical character recognition on still images using the tesseract functions in Emgu-CV. In this video, we're going to use Emgu-CV and VisualBasic.net in Visual Studio 2010 Express Edition. This video is going to presume the knowledge of the previous videos. Please view the previous OpenCV and Emgu-CV tutorials if you have not already. Let's get started. Okay, so we're going to find if we type tesseract into a general internet search, probably the first page that will come up will be the Wikipedia page for tesseract, which tesseract in the general sense is this fancy three-dimensional shape here that can sort of rotate within itself. This is a nice illustration here, but specific to computer vision, tesseract means something completely different. Tesseract is, if we type OCR, a software project. If we go to the Wikipedia page for it, this first paragraph here kind of summarizes things nicely for us. The tesseract software project was originally developed at Hewlett-Packard Software from 1985 through 1995. It kind of had a period of dormancy after that until it was open source in 2005 and then subsequently picked up by Google to sponsor it in 2006. And since then, the tesseract software project has developed to become, really, as far as I'm aware and in my experience, the best general use, free, open source optical character recognition software package out there. So that's what we're going to use today. And then we'll also find, if we go to the page directly, and here we are, first search result, the Google page for the tesseract project, that the tesseract project is available in these separate downloads, similar in a sense to how OpenCV is. Now, the tesseract project is not integrally included with OpenCV, so if we wanted to have an OpenCV program that performed both OpenCV functions and also tesseract functions, we would need to link not only to the OpenCV libraries but also to the tesseract libraries in our one program, which isn't terribly difficult to do, but there's some additional steps. Fortunately, Emgu-CV includes wrapper functions not only for OpenCV, as we already know from the previous videos, but also for the tesseract object. So as long as we're using Emgu-CV, we only need to follow, actually one additional step is all that's necessary to be able to use the tesseract object in our Emgu-CV program, as we're going to see. So let's go ahead and fire up Visual Basic and get to it. Okay, so here we are in Visual Basic. We're going to go ahead and get our project started like normal here, Windows Forms application, and we'll call it OCR. And that's good. We'll choose OK. Before we save it, let's go ahead and rename our form here. So we'll call it FRM OCR. And let's make sure that, there we go, there's our nice name change to our form. And we'll go ahead and save it. So we'll save it, we'll call it OCR, save it to the usual location, go ahead and uncheck Create Directory for Solution. So to expand on what I was mentioning a moment ago, to start with, the first two steps for our linking is going to be the same as the previous video. So first we're going to go to Add Reference. Then we're going to go to Browse, C, Emgu Windows x86, bin, and then we're going to choose 1, 2, 3, 4, 5, 6, 7, those 8 DLLs, and then OK. And just a moment here while Visual Basic adds those, and then we're going to choose Show All Files and expand things a bit so we can see. Then we're going to go to Project and then Add Existing Item. And again, this step's the same as the previous videos, so we're going to go to Emgu Windows x86, bin x86, Show All, and then we're going to include all the DLLs that start OpenCV and end in DLL. So once that include is done there, here's where it's going to be a little bit different. We're going to go to our Emgu install, open up a new Windows Explorer here, so we're going to go to C, Emgu Windows x86. Now what we're looking for here is the test data folder, so we're going to find that test data folder is in bin here. And let's go ahead and expand bin, and then it's also in emgu.cv.ocr. Now these two test data folders, you'll actually find the size of these in bytes is identical. As far as I can tell, these two folders are the same, so it doesn't really matter which one you pick, but choose one or the other. So we'll choose this one, and then we're going to go to Copy. And then we're going to go back to our project, and we're going to right click on our project here, and then we're going to go to Paste, and that's going to actually dump the test data folder and all these files that it includes into our project. Now this next step is especially important here. We're going to highlight all our DLLs here, and then we're going to choose copy to output directory, copy always. And then we're also going to do the same thing with these test data files here. Copy to output directory, copy always. If you don't do that step, this copy always, with the test data files, what will happen is when you go to instantiate the Tesseract object, the program will crash, and the error isn't necessarily clear that that's the setting you need to change. So definitely bear that in mind and go ahead and set that property. Okay, so at this point we're going to start adding some controls to our form. This is going to be extremely similar to the previous video, so I'm going to go ahead and fast forward at this point. Our form's all set, looking nice for us, so we're going to go ahead and have the environment start to write the events for 3 of the controls for us. So for the form, we're going to have the environment start to write the resize event for us. Double click on that, and then back to design view. And then for the button, we're going to have the environment start to write the click event, so we'll simply double click button file. And then for the text file, the text box for the file I should say, we're going to choose the text changed event. And there we go. So bear with me here for a few moments while I neaten up the code a bit. Alrighty, so now we're ready to start coding. So what I'm going to do is I'm going to go ahead and fast forward through the majority of the code, since again it's really pretty similar to the previous projects, and then what we'll do is we'll slow down when we actually get to working with the Tesseract object. So in the member variable section here, we're going to declare the Tesseract object, but then we'll wait until the constructor to instantiate it. Okay, so at this point we're ready to instantiate the Tesseract object, and this could make your program crash if it's not successful, so we're definitely going to want to put this in a try-catch block. So here's what we're going to do. Try, test, is assign new tesseract. And we're not going to want to use the blank constructor there, because then you just have to call the init function later to set the parameters for it. And you notice there's three different options here. We don't really need to use this whitelist option here, so we'll simply use the second of the three. So here's how that's going to look. We're going to put test data. Now note that's the directory, so the fact that we're not specifying a path here is why we have to include the test data folder in our project directly. If you want to specify the path where test data, the folder, is located, you could put it here if you like. But personally, I would suggest that you copy it into your project. That way, if you distribute your project, you can simply include it in the same directory, and you don't have to worry about which directory it's installed to. And then next, we're going to put English. That'll be our language. And then we're going to choose among the options here. You can experiment with these options if you like, but for this video we're just sticking to a basic example here, so we'll simply use the default option. So here's how we're going to handle it if that instantiation is not successful. We're going to do me.text. So in other words, we're going to assign to the title bar the text error instantiating tesseract object. And then to make it especially clear, we're also going to assign the same to the text OCR text box. And then to prevent the user from choosing the button to open the image file, which would then crash the program if the tesseract object was not instantiated successfully, we're going to disable both the file text box and the file button. So that's going to do it for our constructor. Now next we're going to do the form code for the resize event for the form, and then the button click and text file text box changed event. We'll go ahead and fast forward through that until we get down to the process image and update GUI portion of the program again when we get back to the tesseract object use. Okay, so now we're actually ready to use the tesseract object to detect the text in the image, and this is going to be incredibly easy. It's only 2 lines. We're going to do test.recognize img image. That's going to be the image with the text in it, of course, and then we're going to write that out to the text box. So that's going to be text OCR dot text is going to be assigned our tesseract object dot get text. And that's it. Now a little bit more code to finish up our form here. Alrighty, so now we're all ready to go ahead and perform a compile. And there we go. How about that? First go, 1 succeeded. So let's go ahead and fire up our program and give it a test run. And of course we've made our form code so that the image box and the text box will resize nicely as we change the size of our form here. So if we press the button here to choose an image file. So what I did when I was preparing for this video is I downloaded a variety of license plate images. So here we have some license plates in scenes as they would actually be found on the road. And then here we have some license plate images strictly of the plate only. And then this last set of images here, this is for word processor images. Actually, I typed these up in a word processor and then took screenshots of the word processor and then saved those to an image file. And then these 4 here are license plate crops from some of these license plate images here. So in future videos what we'll do is we'll take, if you have a license plate in a scene, how do you narrow down to focus in on just the license plate, and then once you have the license plate, For example, if you have this New York Stonewall, the Empire State license plate, of course we're only trying to read the actual letters of the license plate that identify the vehicle, so that would be Stonewall in this case. Of course, this is not a real license plate. But how do we section out New York and the Empire State and then only read the Stonewall part? Well, if we go ahead and look at this result here with the tesseract object with no pre-processing of the image, we're going to find that New York is not read, and Stonewall, what we're really trying to read, is not read, but the Empire State, which we're not really trying to read at the bottom, is read, and also the slots here for the bolts are read as the letter I, which obviously they shouldn't be. So in a future video we'll get to the pre-processing steps so that you're feeding that tesseract object basically perfect characters. But for this video, since this is just a basic intro to the tesseract function, we'll essentially start with perfect text, and then we'll cover the other stuff in future videos. So let's start out with these word processor generated image files here. So here we have Times New Roman font going from 8 point up to 24. So we can see that for 8 and 10 point, that's pretty small, and the tesseract object has a hard time reading that. So for the 8, it basically doesn't really come up with much. For the 10, it's close, only it reads point as paint. But for everything 12 and up, you can see it's dead on. So then if we look at the larger sizes, we'll also see pretty similar results. Here's 26 through 50. The only imperfection here is that for 50 it puts a space in between the 5 and the 0, but that's pretty minor. And then for 60, 70, and 80, the only imperfection is that the 0 and the 70 and the 80 is read as the letter O. And then for 100 and 120 point, it's dead on. So let's go ahead and take a look at some of our crop license plate here. Here's the Stonewall plate, and that's perfect rendering there. And then we have the sample plate, and that also came out well. And then these last two are a little bit more along the lines of what an actual plate would be. So here we have this 679 plate, and then we have this XCG plate also, and the tesseract object is able to read all those very nicely. So that completes our introduction to using the tesseract object within Emgu CV. Congratulations! You now know how to perform optical character recognition on still images using the tesseract functions in Emgu CV. See everybody next time.